So welcome to the last question. It is a completing the square question that we start off with, and we go on to quadratic and inequality problems, but we'll start off with this. We'll start off with this completing the square. We have to change this equation here, or expression, into this one right here, with p and q being real integers. So how do we do that? Well, let's start off. Let's write that down there. 2x squared minus 20x plus 53. So the first thing that I am going to do here is take 2 out of this and this, out of the left and the middle terms, so that I get 2 times by x squared minus 10x and then plus 53. We're going to leave that 53 alone actually for the first few steps of this, but the reason why I wanted to do that is because it's much easier to deal with this system here when it's only a single x squared. So if you can take out any multiple of that you might have, then it's much easier. So the system that we use to change it from an x squared minus an amount of single x into this sorry, x minus p squared, is what we're going to do is we're going to leave that 2 out there and then say, right, we've got x and then halve this, halve that, so half of minus 10 is minus 5, square everything, then take away this one squared. So you imagine minus 5 squared here. So minus 5 squared is 25, so let's take away 25, and you always have a minus here, so it wouldn't matter if this was plus 3, you would still take away 9 from there, so you always take away what's in there anyway, and this 53 just carries on here. Like I said, we don't touch that for the beginning. And then actually this, I should have made this clear from the beginning actually, this 2 here actually encaptures all of that there, because we've taken that and it's this bracket here that's turning into this pink one there. So everything, this x minus 5 all squared minus 25 is the same as what's in this purple bracket here. So let's move it on a bit. I'm talking too much, I think. So let's times it out. So we've got 2 times by x minus 5 squared minus 50 plus 53. That's what we've got there. And then the last step is obviously to just put these two together. So we get 2 of x minus 5 all squared plus 3. That is our answer. That is the form they wanted it. That is our answer. So let's move on. Let's do the second part of this question. So use your result to explain why it has no real roots. So none at all. So no real roots means that, what does no real roots mean? No real roots. Well, if we have some x squared, so normally we'll have some x squared and it will, let's say it does this. This is just some random x squared function that's got some x squared in it. So this will have 2 points of intersection. There's one and there's another. That's points of intersection with the x-axis. I'll make that plain. So these are our roots. These are what are classified as real roots. So what we've got, if I draw another one, is what we've got is a function that, because of this plus 3 here, because of that, ours actually does not touch the x-axis. The lowest point here is actually at y equals 3. This is our y-axis. So this point here, that will be 3 there. So we have no real roots there. So what can we say for that? Well, we can say two things. So the first one is that x minus 5 all squared is greater than or equal to 0. It has to be. Whatever x it is, it has to be. And we also have plus 3 is greater than 0. Plus 3 is greater than 0. So there are no points of intersection with the x. So you can say, you know, therefore it has no real roots. Therefore it has no real roots. So that is our answer for that one. You just have to explain it. So the next question, we have this new quadratic equation here, and we get told that it has real roots. So this one does cut through the x-axis. And how do we prove that? Let me go down slightly to make space. Draw a line there. So it has real roots. Well, we know from the quadratic equation, and we write that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So the bit that we are interested in is this part in here. So what we want, this is a 5, I should make that clear, that's a 5. So, not a 5, sorry, that's a b. I've confused myself there. Let's go back. So this is just a b there. So what we are saying here, by saying it has real roots, we are saying that this, under this square root, this is positive. This under the square root is positive. If it was negative, then we would have no real roots. Okay, then it would just come up here. But because it's positive, we are saying that we have 2 points of intersection. So let's do b squared minus 4ac for this equation here. So what's our b? Our b is going to be k plus 1, so squared, minus 4 times by a. A is this here, this 2k minus 1, and then c is k. So I'm going to put 4k there. That's 4k amounts of 2k minus 1. So let's have a new colour for that. So let's have green. So let's just times this out. So we're going to get k squared plus 2k plus 1 minus 8k squared plus 4k. Be careful there not to make a mistake. So plus 4k at the end. And then what are we going to do? Well, let's try and group some of these together. So we're going to get a minus 7k squared. We are going to get a plus 6k, and we are going to get a plus 1. And what we are saying is that this, because it has real roots, this is greater than or equal to 0. So this might not be immediately obvious, actually, this last step that I'm going to do, but I'm going to times everything by minus 1. So times by minus 1. Go over here. So we're going to get 7k squared minus 6k minus 1 is then going to be less than or equal to 0. And that's just to get it into this form that they wanted it there. So when you times by minus 1, you flip this greater than or less than sign around. So let's move on to the very last one, hence find the values for k. So we have, I'm going to go down a little bit here, hence find the values for k. So what we are going to do is act as if this what we've just found, as if this was our normal kind of quadratic. So if we say that 7k squared minus 6k minus 1, we need to get that into two brackets like this, where we have x plus something and maybe x minus something else. So that's what we have to try and get it into, like that, except it's going to be a 7 and it's going to be something else. So what is that going to be? Well, let's see how we do this. So we have a 7 and a 1 here, so that's going to be minus 7. So we need two numbers that times together to make minus 7, and add together to make minus 6. So I think that is going to be minus 7, so 7k squared, minus 7 and plus 1. So minus 7k plus k minus 1. So notice I haven't changed the value. Minus 6k is the same as minus 7k plus 1k. It's exactly the same. And then I'm just going to factorize them. So 7k comes out of the first two terms to get k minus 1, and then plus 1 amounts of k minus 1. I hope you've done this before because I'm going through it rather quickly. And then we get 7k that we get from here, and the plus 1 that we get from here, so 7k plus 1 times by k minus 1. And they are our two brackets that I talked about over here. So let's try and find out what the critical points are. The critical points. So the critical points are on a traditional, if we have a, I'll try and make that straight, if we have an x squared looking curve, then the critical points are going to be these points here, these ones here. So we're going to try and find out where they are, where these are. So k minus 1, so we're going to get k is equal to 1. I know it's not equal to 1, but it kind of is. I hope you understand what I'm trying to say. It kind of is equal to 1. So we're going to get a point here at k equals 1. And we're going to get another one. You can think of this as y, and think of this as k instead of an x. And then here we're going to get k is equal to minus 1 over 7. So this here, this is going to be, it's obviously not to scale, k is equal to minus 1 over 7. And what we are saying with our function, here we go, our function is always less than or equal to 0. So we are looking for the only place where this graph is less than, is below the k-axis. The k-axis, just like the x-axis. So it's just this from this point to this point is where the function is below this axis. So we can say that from minus 1 over 7, anything greater than or equal to that, we have our k, and then it has to be less than or equal to 1. So in that range, we have our k is less than or equal to 0. That is our answer. I hope you followed me through that. That is the end of our exam. Well done if you made it this far. See you on the next one.